Hi there, everyone. Today we're going to talk about sampling, which is another way of saying how we're going to select our participants. So, sampling is basically the process of selecting observations or individuals from the greater population. This is what we do when we're wanting to perform some research. You want to be sure to get a representative sample, and that's the overarching goal always. And we have a couple of things in our past that tell us about getting the wrong sample and what happens. And we see this in political polling. And the political polling back in 1936, the Literary Digest poll mailed out 2 million ballots to people who were listed in the telephone directory and also the auto registry. And they asked people who they were going to vote for, and they got an abundance of answers saying that they were going to vote for Alf Landon. So Literary Digest predicted Alf Landon to be the winner of the 1936 presidential race, which of course we did not have President Alf Landon, we had President Roosevelt instead. And one of the reasons that we saw that was wrong with this was because their sample was not representative of the entire population it was supposed to be representing. Because their sample consisted of people who were listed in the phone book or the auto registry, they were actually gathering a sample that was more affluent. In 1936, not everybody had a phone, and certainly not everybody had a car. That was pretty limited to people that were more financially secure. So they weren't getting a representative sample of all of the income levels in the U.S. at the time. After this happened, there was a gentleman that started the Gallup, which we still hear of today, the Gallup polling. He started a type of sampling which is known as quota sampling, and he went on to successfully predict the next few presidential elections until 1948, when, because of Gallup's quota sampling, they predicted that Thomas Dewey would be the president over Harry S. Truman. And you can see here there's a picture of Harry S. Truman actually holding the Chicago Daily Tribune that states that Dewey defeats Truman, and as we know, he did not. And the problem with this was, and we'll talk about quota sampling in a little bit, but quota sampling has a problem of not knowing exactly which variables are going to represent the population. There's a lot, because the population itself is individual people with we have a very different makeup from people around us. So we will talk more about that, but just know that sampling in some ways sounds very simple. I have a very large population and I need to gather a sample of that population so I can do some sort of research. However, there are some actual key mistakes that we can do to end up with a sample population that doesn't represent the entire population we're hoping to represent. So let's move on. Some of the things that are important about selecting research participants. The sample that you're selecting, you want to definitely come from the population that you're interested in. Now, one of the things we're going to do with this, most likely, is we'll run inferential statistics. We will also probably run descriptive statistics, but the inferential statistics are when we run an analysis that we're hoping that we can infer to the entire population of interest. The sampling frame is the list of the entire population from which the sample is being drawn. We have probability sampling, and this is when you can specify the probability that a participant will be selected from a population. So if I have 100 people in my population and I put all 100 names into a hat and I reach in 10 times and I'm going to draw out 10 names, there is a 1 in 10 chance that those, or 10 in 100, chance that your name would be selected. So we know the probability of your name being selected. Then there's a non-probability sampling. And non-probability sampling, it is impossible to know what the probability is of getting selected. And with non-probability sampling, the sample may or may not be representative of the population. Now, for probability sampling, the first thing that comes to mind, for me at least, is random sampling. And random sampling is a sample that's drawn, that's kind of actually what I had just talked about, where you put the names in the hat. What it is it comes down to each person in the population has an equal probability of being included in the sample. And something that you want to keep in mind when you're talking about random sampling, this is not the same as random assignment. Random assignment is such that after the sample is already created, and maybe we're going to take our sample and divide them into 2 or 3 or 5 groups, that you have an equal chance of being in any of the groups. That's random assignment. Random sampling is when you get selected to be a part of the sample. A depiction of random sampling, you can see we have our miniature or micropopulation on the top of the screen. We have this as our micropopulation. And then we just generated some random numbers through a computer-generated random technique. And we're going to just take the last 2 digits of these random numbers, and these are the people that are going to be selected. So it's just absolutely random, and you come up with your sample. So this is a random sample. Some other probability sampling techniques are systematic sampling or stratified sampling. For systematic sampling, the population size is divided by your sample size to provide you with a number k, for example. Then you're going to pick a starting point from a random, and you're going to select every kth individual. So if I have the 100 individuals and I would like a sample size of 10, I'm going to go every 10th person, and maybe my starting point would be 4. So the 4th person, the 14th person, the 24th person, the 34th person, the 44th person, and so on. For stratified sampling, the population is divided into different strata, which might be something like gender. So I'm going to have the female and the male, different strata. And then the participants are randomly selected from each stratum. So this might be if you have a large population, if you have a population that's very heavily represented, maybe 90% males and 10% females, but you want to be sure to get females. So you don't want to lose the females in the randomness of it. You want to have a representative proportion of the females. So you might want to do a stratified sampling. Some other ways for probability sampling are cluster sampling or multi-stage sampling. Cluster sampling can be used when a population list is not available and researchers simply identify a number of clusters or groups and include all participants in the cluster or group in the sample. And a multi-stage sampling is a cluster technique where smaller clusters are randomly selected from larger clusters that were randomly selected previously. You always want to be aware at every step in research of your conscious or unconscious bias, which we can have with sampling as well. So the bias is that those selected are not typical or representative of the larger population for whatever reason. Representativeness is going to define the quality of the sample. And what I mean by that is we're saying that this sample has the same characteristics, similar distribution of the characteristics, similar spread of certain variables of the population that they are trying to represent. Now, the samples don't need to be representative of all the aspects, but the ones that are relevant to research. So if age has nothing to do with research, then you don't have to worry about age. If age has something to do with research, then you would want to worry about age, which a lot of times age can be influential in a lot of research. And now we can move on to some non-probability sampling. This would include convenience sampling, quota sampling, referral sampling to start. Convenience sampling is when you're going to use a sample of participants that are easily or readily available. It's one of the times I think of convenience sampling, it's very often that professors will use the students in their class or the students at their university because they are available. There's also quota sampling, and we mentioned this earlier in the lecture. This is what we saw from the Gallup polls. And this is a type of convenience sampling in which you want to select participants with a specific characteristic until you have enough. So back to the Gallup poll, they wanted to have a certain proportion of liberals and a certain proportion of conservatives. So as soon as they got, I think it was 45% of one and 50% of another and like 6% of undecided or something to that effect. As soon as you reach your quota, then you don't need any more of that particular characteristic that you're looking for. And again, one of the problems with quota sampling is if you're only looking at, let's go back to the political example, if you're only looking at liberal versus conservative, are you also considering race, or are you not considering race? Are you also considering age? Are you not considering age? Are you considering what state they live in, what state they don't live in? So there's all these other variables that typically go into why somebody would make a political decision. So if you're doing quota sampling, which quota are you going to, which characteristics do you feel are important to meet that quota? Referral sampling, and it pretty much what it sounds like, it's when the participants that are in the sample can refer you to other participants. And we do sometimes see this when we're doing maybe groups that are belong to a certain clubs, organizations, things like that. You know, hey, do you have a friend that would be willing to share their story, kind of thing. So we definitely use this. There's also snowball sampling, which is another non-probability sampling. And that is what you're going to see when you kind of just cast a wide net. And again, you're going to use referral, where you're going to ask people to refer you to other people. You're going to ask people to suggest to their friends that they join. This is something you can see that can be used with special groups. So maybe you want to know something about gymnastics training. You're going to want to ask a gymnast who her other friends who are also gymnasts, versus trying to just go to the general population and trying to find gymnasts. It doesn't always make sense to do that. The other time you might see this is now with the increase in all of the technological tools that we have. You see a lot of like Facebook. I think of immediately like Facebook surveys or the internet type surveys. That's going to be a snowball. Like somebody posts something on on their Instagram or Facebook. Can you please take this survey? Can you pass it along? Determining what sample size you're going to need. This is one of the biggest questions always. What kind of sample size do I need? And it has a few different things that you want to consider. The power of the statistic that you're running, the research design that you have, like how many conditions there are, how many variables you're looking at, what size of effect you're hoping to be able to identify, whether it's a small effect, a medium effect, or a large effect, and the variability of the data, what data it is that you're working with. And all of these things would be taken into consideration to determine what sample size you want. Now, the general rule of thumb, and this is very loose, but the general rule of thumb is the larger the sample size, the better. However, there are actually ways that you can determine which sample size is needed to be confident in your results and what you're trying to infer. Whoops, I'm sorry, went the wrong way. And another reason that helps with increasing your sample size is this also will increase your power. When you're deciding what sample method to use, you want to consider, how much time do I have? How much money do I have? How much help can I get? Because these things are all going to be very important in finding and gathering a sample, collecting a sample of willing participants or participants in the specific field, hobby type that you need. Sampling error is the degree of error to be expected of a given sample design. And this is something that, again, when you're running your statistics, this might have slight influence on your results, and it's something you want to consider when you're designing your study, because there's always going to be a little bit of error in your design. Your sampling frame, it was mentioned earlier, but it is the list of all of the units that compose the population. So it's the complete list of everyone or anything or everything that you want to study. This is where you would go to gather your sample or to draw from for your sample population. If the sample population is to be representative of the population, it's extremely important that the sampling frame include all of the population. So if you really want to know everything there is to know about the freshmen at your university, it would be very important to have your sample frame be all of the freshmen at the university, not just the freshmen in the sociology department. So if you're going to use an informant, it's good to get an informant that actually knows what it is you're studying. Otherwise, that would be kind of a waste of a conversation, maybe. The informant is somebody that knows a lot about the field or the phenomenon that you want to study, and they're willing to educate you and tell you what it is that he or she knows about it. If I were doing some research maybe on why people tag buildings and bridges and overhangs, the spray painting or leaving their mark, it would be very beneficial for me to talk to someone who does tagging, who knows some of that world. It's a little bit of it's a slightly underground world, and understanding what it is that you might want to research or some of the variables ahead of time can be really beneficial to your design and your study in general. So it will also help with the sampling. An informant oftentimes knows people that can also help get you into certain populations or introduce you to certain populations. And that is what I've got to say today about sampling. It looks like my dog is already bored with this lecture, so I'm assuming you are too. Just kidding. Thank you so much for listening, and I hope you all have a great day.